technology has been used by many cultures, like in the ground and everything. But the thing about Shamota bricks is they're kind of adobe bricks, and I don't know specifically how these are made, but originally they were made with omegush inside in the mix when you mix them. And what happens is when you burn them, they have air pockets inside. Okay, and that means they're also insulated. So they have a combination of thermal mass. They can get very, very hot. The first time I built one, the fire burns inside, and I naively touch it from the outside. Don't do that. So they can hold a lot of heat, and this is different, like from a regular brick, which will probably break. It will not get as hot as this. Okay, so that's the thing about Shamota bricks. You can get them in any Baumax or Dedeman, or I think you can also make them. We plan to, but we haven't manufactured any ourselves. Basically, adobe brick, if you have a formula for adobe bricks, add omegush into the mix. When you burn it, you get the Shamota brick. All right? I will build it. I will not speak as I build it because seeing is believing, and I'll start talking again when it's burning. All right? I'll explain some of the features of the construction after they're built. The fuel will be put in from this side. So you're in the back, you're in the front. If people want to see it coming up from the front, you should come to this part.
Ronald, while you explain, can you please speak a little bit slower?
Yes, thank you.
Building a rocket. So
is anybody measuring time? Just so so you can see how crazy simple this stuff is. If we had half bricks, these wouldn't stick out. So you can basically cut one and we'd have half a brick. All right. I'm finished. If we had 4 more bricks, it'd be better to have another layer up, and you can actually do 2 more layers, and you'll see what it matters. So I'll be I'm kind of improvising to create another small layer. But I'm finished. I just built a rocket stove oven. All right, thank you. Kidding. The wood was just collected within about 2 square meters of where I am. I didn't go anywhere to get anything. Everything is here. I'm looking for the small ones just to get, this is great, just to get it started. You know what, first, wait. You've all burned a piece of newspaper in your life?
Not that one.
Not this one. Yeah, they told me activist papers burn better, so. But before I light it, I'm just going to light this piece of paper and put it inside. Okay, and this is all the energy that I'm putting into the rocket stove. Look at the intensity of the flames for 1 piece of paper. It hasn't started working yet. This is just to show off. It gets much. This is still 1 piece of paper. Okay? So now let's get it going. I burned quite a few papers when I just lit it up because it was so entertaining to watch.
Is it still alive?
Yeah, there's still ambers inside. It's still kind of fading out. So I'll talk in a minute about what happens when wood burns and where was this? Another piece ready. Feel free to come and peek, and you can come close and. I'm just putting small sticks in just to get the fire going. The best is yet to come. it'll take time for it to heat up. I just want to get it burning, and then I'll start talking about what is actually happening here. And I should say, I'm not good at lighting fires. It's new to me. There are people who've been doing this all their lives. Alright, it looks like it's catching on. Now the thing to know about rocket stoves, because it uses so little wood, is when you start it, you have to feed it carefully. If I put in a lot of wood now, the temperature quickly drops and it loses efficiency, it may go out. So when it's just getting started, the idea is to feed wood slowly, carefully. Once it gets hot inside, remember this is shamota bricks, so it's going to get really, really hot here. So does anybody, I don't know how to say it in Romanian, there's it's a danger in a regular home with a chimney called the chimney fire. While the black soot accumulates, you know about this thing, and the chimney can actually catch fire. This is
aprinde hornul. La asta se referă, nu?
No. This is actually a systemic chimney fire. Okay? This is a chimney fire by design. All right. Now, I don't know if you noticed, but the smoke is kind of stopped. Remember this thing where there's fire, there's smoke? There's no smoke coming out of here. And it's still not burning at maximum capacity. It's still just warming up here. And when you put a pot on top of it to cook, it actually blocks the escapes of gases, so it burns even better. So this is like the worst burning you can see in a rocket stove. And you can see the rocket. You saw what kind of wood I put in here? I'll keep talking. You look at the quantity of wood here. Let's see how much we get through. I don't know how long we stay here, and I'll answer your questions. And so what's happening? What's happening is this. You know when you buy these centrala for your house, and they have the expensive models with the gasificale?
Yes.
Burning of the gases? Okay, that's the 70% of smoke that you see. That's what these things burn. Now the reason the regular stove doesn't do that is the gases need a much higher temperature than the wood does. Okay, so if you just burn the wood, it gets to a certain temperature. That temperature is not enough for the gases to burn. Okay? Este cu gasificale. Because the bricks get so hot. I'm not kidding. I have two of these big ones at home, and we only emit carbon dioxide. Okay? Somebody asked me here, I should say, how much more efficient this is in a regular stove? It's not 20% better. It's about 5 to 10 times better. So 20 to 10% of the wood for the same amount of cooking or heating your house or whatever you're thinking about. So
Actually 3 times better.
sorry?
So actually 3 times better.
5 to 10 times better. 10-20% of the wood for the same amount of cooking or... I didn't put it out right? No? You're okay? Alright. No, it's fine. So the first thing is we're creating temperature for the gases to burn. Okay, you see what happened? I put in a thicker piece of wood. I put it in a bit too deep and too early, and smoke again because the temperature has dropped inside. Okay, and then it kind of fixes itself. It got hot again, and the smoke will soon stop. The batch of wood that I put in originally still hasn't finished burning. So the first thing is temperature. This is going to get very hot, and the gases are actually going to burn in here. The second thing is when I prevent the gases from escaping by simply putting a pot on top of it, those gases stay for a longer time. Okay? So there's actually three things. I've mentioned two of them. Temperature and time. Okay? So I need the gas to get hot, and for that I need it to stay longer. If it was just a chimney, then the gas would just go out, and that's the smoke you see coming out of the chimney. So I need to stop the smoke. I need to stop those gases and keep them here. So a pot, just putting a pot on top of this, that's what it does. Okay? The rock is here, something technical that should be said about operating it. If you come in the front, you'll see that you notice that the brick that I put at the bottom is one of these. It's a thinner brick. Okay? And this rock is a bit taller, so if I put any sticks of wood in, the air comes in from the bottom. So I don't want to block the flow of air. So it's air on the bottom, wood on top. And what happens is, the only way air can get in is through here. Here it's escaping. So it has to get sucked in from beneath the wood. And what happens is, if you just one time or come and look, you see that actually only the edges are burning. The fire is not making its way out. It's not trying to get out. It can't because the air is sucked in. So the air is kind of protecting the fire from spreading. It's keeping it burning just on the edges. You get out of your way and you can all see this. So Shamota bricks. They keep heat very, very well. They call Shamota bricks. Yeah. And I'll get the fire going stronger a bit. Now I'll put it on the edge here, just a bit of a bigger stick to get it started again. Go. I'm so proud of myself for not having to put it in a piece of paper. Sure. The organizer, I needed 4 more bricks, okay? And I'll answer the question extensively, okay? The basic mechanism, I started to describe a draw mechanism, okay? The air is drawn in and the vertical chimney, okay? The taller you build this chimney, the stronger the draw, okay? So, like, see it coming again? A basic structure should have 1 more layer of these bricks. Okay? At home I've actually got another layer on, so it's just a matter of how many bricks. It's 4 more bricks for every layer. And at home we've actually got 2 side by side, so like comes the Kuska time in about a month. These, we're sitting outside for 2 weeks, burning rocket stoves and pots on both of them. This is, alright, now the big one is coming alive and it's just going to burn forever, you see. So this L shape is the key design feature, and the fact that this part is a chimney and it's insulated. If it was anything else, the heat would escape outside, and then
other bricks it wouldn't work this
it would not burn as well. I've tried it, and there's 2 problems. If you build it like I just built, there's no mortar here. I just laid the bricks down. You saw, I didn't glue it. I didn't anything. You can build it more permanent and more long term if you want to. You can make it more efficient, and I'll get to a few things in a minute. But it's because yeah, but it's still burning like crazy. I mean, have you ever seen so little wood burn so strong?
No.
And it's still not hot. It'll get hotter. And there was one point, if we had a pot here, we put it on, you'll see fire shooting out. Really rocketing out. I can sit for hours just looking at it. One of the features I don't like about this basic design is that it takes attention. You have to keep prodding the wood, okay, inside. And this is where design gets more complicated. I'm not going to get into that today, where instead of it becoming an L shape, it becomes a J shape. So imagine that there was a bit more of a structure here, and the wood was actually fed vertically. Okay? So the wood actually would burn here. And that's the next magical thing, to see fire shooting sideways. Because your intuition says if this wood was here, the fire should have burned up. But remember, the air is being sucked in here. Mm-hmm. So the fire cannot go up. It's extinguishing itself. So the only way the fire can burn is at the tips and sideways. And this is a small one. The one at home is like, it's a longer J, and it's amazing. You can look inside, and especially when you build it before, and I'll talk about the more complicated aspects of it, you see flames that are like, the wood is here and the flames are this long and turning a corner. You can look inside and see the flames shooting up. And it's not wood. There's no wood here. The wood is just like about here. Imagine flames this long turning upwards. Okay. Now you see again the bigger piece of wood is it's very light wood, by the way. It's not very massive. You can see it. And at one point there's just no smoke anymore. It'll just burn and burn and burn. So this is the outside thing. Because it does occasionally emit smoke and it does require attention, I wouldn't build this indoors. Okay? Everybody clear about the basic technology about, and you again, do not take my word for it. I just want to get it going stronger. Okay, so you can make it taller. And the greatest in energy efficiency, the greatest fault in this design is actually heat transfer to the pot. Because again, these flames are coming out, okay? And I'm kind of sorry that we didn't get a pot here as well, because once you put it on, you can see that the flames shoot out. So a lot of the heat actually does not stay with the pot; it just dissipates. So there are, like the Americans who've been doing this for a long time, they build these from a steel drum and insulation side and all this, and then the pot is completely, it's kind of half inside. So it's not only at the bottom of the pot that is getting the heat, but actually the sides of it. So you lose as little heat as possible. That's how extreme you want to get. To me, just the fact that 5 times or 10 times better than what you would get from a regular fire. I'm kind of, and I didn't cut any trees for this. Still I haven't touched anything here. There's only one that I'm relieved. There is ashes built up. Again, it depends on the kind of wood. Like any stove. Pine creates more ashes than hardwood like oak or something, or Kharkoum is great in this, but much less than you would think. Again, because the wood is being burned completely. Okay, this is again the 3070. Yeah. I've never had to empty this in the middle of the day. I can go on cooking with this all day, and the ashes will not get in the way of cooking. At the end of the day, there will be a small pile.
We'll see after an hour.
I'm the philosophy of don't believe me. I don't believe anybody until I do it myself. And so now to take this indoors. Any more questions about this thing? That's really all there is. What drives me crazy about it is so simple, and everybody should know how to do this.
Is there a recommended size? Like, can you?
You're looking at it.
And if you are doing a G shape,
the J shape requires a bit more of. You need more bricks to build
the same height or the input is lower than that?
It becomes more complicated. There's a book on rocket stoves, and I recommend anybody. It's on the one hand, it's a really do-it-yourself technology, but if you're going to build what I'm going to talk about in a minute, the rocket mass heaters inside the house, read the book twice before you play around with it. You can get it wrong, and you get it wrong, you'll get. The worst case scenario is you'll get poisonous gases in the room that you don't even know are there, because there won't be smoke, but you will poison yourself. So it's a do-it-yourself thing. Yeah, it only happens once. After that, you're relieved from worrying about it. So. It's not a game. It's a do-it-yourself technology. If I can do it, anybody can do it. But know what you're doing. There are things to know about the dimensions and proportions. The chimney needs to be taller than the feed. Okay, so there are things that you need to know, and it takes playing around. It didn't work great the first time I built it. It worked better. We always built a model before you build the one inside the house. But let me say something about what a rocket mass heater is, because this is not a rocket mass heater. When you're talking about indoors, the question then is how to keep the heat inside. So we're creating this really efficient fire, but again, if we do it, but now it's attached to a chimney because we don't want the smoke inside the house. What you're doing is taking the heat out. Okay? And rocket mass heaters, I should go back and say that there are a few ways to get yourself warm in a room. Right? The most difficult one is to get the room warm. Air does not have thermal mass. It does not keep heat. And this is how most of the world does it. You try to get the room warm. Okay, that's the wrong way to do it. The best way to do it is have the heat where you are. So rocket mass heaters talk about, and I can't get into all the details. I think it would be too complicated in this setting. But the idea is to imagine that this unit is burning, and it's attached, instead of going out to a chimney, it's attached to a bench. to a cob bench, a couch made of cob. And instead of running the chimney directly up, you can run the chimney inside it horizontally. Okay, so you can like go back and forth. Imagine it was all the way here. It goes back and forth, and then the chimney goes out. Now, why can you cannot do this with a regular stove? You'll get smoke back in the room. You can do it with this because what happens? Sorry. Because this becomes the pump. When you build a full rocket mass here, it's like the chimney is about this high. You put. I'll explain why you put a butoy over it. But it becomes pretty big. Okay, and it's actually a pump, so the gases are not floating out because they're hotter. They're being pushed out. Air is literally sucked in. If you hold the match, even if you do it now, when it gets warm, you hold the match, you will see the match getting pulled, the flame getting pulled inside. So it's a very active thing. It's not the smoke rises. The smoke is pumped through. So depending on the size that you build. Sorry, I lost it. Now it will shoot out the fire because it's getting really hot inside. Take it. The bricks are much better after using them a few times because they get harder. They're terrible after winter when they're moist. If you're like me, you do a stupid thing and leave them out in the rain. And so what happens is, instead of letting the heat go out, you store it in this bench. And that means you light the rocket, and the bench gets warm, and the heat stays there sometimes for 24 hours because the heat is really, really intense. It's like, I haven't measured it myself, but from what I've read and saw from other people, it's like 700-800 degrees inside the mass heater.
So the bench is made out of these bricks?
Yeah. Actually, no. It's pretty. To do that from the bricks is pretty expensive. You build it from cob. We haven't done that, by the way, because one expensive element, especially here in Romania, one expensive element is the pipe itself. Okay. To get good pipe, I'm not talking about the cheap stuff that's available in the village, the aluminum, which after a year it doesn't really work anymore. To get good steel pipe, it's pretty expensive. So we haven't done it that way. We built it in other ways, and again, I won't get into all that. I think it's too much. Come back. Don't know if that's enough, but it's okay, got it. Thank you. I think some of the wood here is a bit moist from that rain that came here. But the thing is, it quickly comes back. Like when it's hot and I'm cooking something and I forget it, it can go out, and you put a stick back inside and it lights up because again, it's super hot inside.
No, it's actually the system of a pocket haber, no? Open fire, because it gets the oxygen from all possible parts. And
that's the most efficient because it's sucking air from everywhere and it's burning to everywhere. This is a very directed. Actually, the thing about rocket stoves inside the house are kind of boring because you don't see a fire. They're really safe because you cannot get into the fire. What's nice about them, they have a hissing sound, like a dragon breath, and you can hear it. And that's when you know you need to feed it again. And you don't run it all day. We run it for about 2 hours, maybe 3 hours at the height of winter, and once in the morning, once in the evening, and that's it.
I have a question. If the house is very insulated,
Yeah.
then there is no or very little air flow. If the house is very insulated,
If the heat stays inside, then you can light it once a day, and maybe that's it.
But there is a little bit of air.
Where to
that
get
goes.
air? Okay.
Yes, how does you get air?
So I will fix the question a bit. The problem is not insulation. The problem is air tightness. Okay. The rocket needs air, and this is a good question. Okay. We live right now in an old, traditional Romanian home, and we don't have the problem of it being airtight. There's plenty of air coming into the house, and that's a relief because it's no problem. But if you have, like, you're building a new house and it's airtight and everything, then you may need to provide a supply of air from the outside to it. Again, the whole mass heater thing is a different story altogether. It saved us in the first year because we were new to living in a village. We didn't know how much wood would be enough. Had we not had a rocket stove, we would not have gone through the winter with the amount of wood that we had. So I'm very grateful for the technology. Questions? I said it's simple.
Can I make a comparison between the traditional stove? I mean,
Yeah, the traditional Romanian stove.
the most complicated ones that have multiple rooms. So the smoke does not come out straight. You have a burning. The smoke goes like this and then outside.
So they're good at heat retention, but their burn efficiency is not necessarily high. They don't use the same wood efficiently as the rocket stove. So there's also the quality of the burn. We have. I mean, you will get ashes here in the rocket stove at home. We get really very little ashes compared to. At first we had like this. We had a metal stove. We didn't have the traditional stove, and it generates tons of ashes. Again, to me, this is precious stuff. I haven't touched this pile yet. I've been talking for a long time, and we could be cooking on it. And look at the wood.
Maybe I have the experience from the Baltic Sea region. We had kind of these ovens for a Romanian house, Konak. We built them big enough so we could put just on the ground without any, gratar. So we could meters. Just cut it on meters.
Meters
We
of
put
wood
inside.
inside, yeah.
The only problem what you need, even if you, for example, if you build a barn, is that you have a chimney that is high enough to have the...
To create the drop.
Yeah.
Yeah.
So there is some kind of formula, I don't know it, but...
There is proportions, and I won't get it's mathematics. It's not complicated, but you need to know it before you play
It
with it.
was like, if you go like this, you need 2 meters up for 1 meter like this, and if you go
About
back
twice
3 meters...
about twice as
If
high.
you go backwards, 3 meters high, huh?
But I should say this, I fell through the same trap. I call it the trap of laziness.
Yeah.
I want to feed wood once and forget about it.
Yeah.
It doesn't really work. There is a dimension where it becomes optimal. And if you go beyond that, it may serve your purpose, but it does not become optimal anymore. So you may get a really, and there are people playing around with it like to crazy, degrees of, like building it, imagine 2 bucklers high, not 1.
Okay.
And a lot of drop, but the burning efficiency is not as good. So the guys who've been doing this, have been doing it for 40 years, have tried all the options you can think of, and the formula that they offer, it works. And again, we've been living it for 2 years, and you may want to get extreme, but usually you're compromising something in how it works. You can create too much heat. Like we built one at home, where instead of a bench, it had a small. It's built of shamota. It's like a buta of shamota. It's like a box, a shamota box, and we put a stove, a metal stove inside. And I thought, wait, maybe we can use the heat to bake. But what happened is it heats the room too fast that the stove never gets warm enough to bake.
Okay.
If I wait for the stove to bake, it'll be a sauna in the room. I mean,
One option.
When we finally built the one with the butoy on it, you cannot imagine, if you're standing next to the butoy, within 2 minutes you cannot touch it. The metal barrel, within 2 minutes you cannot put your hand on it.
Can you heat water with the gases?
Answer is yes. You won't find a lot of information about it because it's dangerous. The problem with heating water is, and pressurized water, is that it expands very, very fast. Much more than a regular fire. This stuff is really, really hot. So, see, this is the part I don't like about it. It takes attention and... So I just got, actually, there was a big workshop in America. I couldn't, it was too expensive to go, but they filmed like 4 DVDs from it. And that's the first time they made information public on how to heat water, and I'm looking into it for this winter. Absolutely, yes, but it has nothing to do with the rocket stove, it has to do with water safety, hot water safety. This thing can explode. When you put water pipes into it, it can explode. The DVD, by the way, is called Boom Squish. That's the name of the DVD, because and the people behind it did not want to give this information publicly. They said you can do it, but you really have to know how you work with hot water. It's nothing. It's not. The problem is not the rocket stove. The problem is hot water and pressure, because the temperature difference between water coming in and water coming out is so huge that it can expand like by 100 times in seconds. So you need pressure tanks. And you need to know what you're doing with hot water. It's not about the problem is not the rocket. Yes, you can heat water with it. You can cook with it. You can heat an entire home with it. It's efficient heat. You can do almost anything with it, but you need to do it safely.
One more question. Can you control the burn rate?
All right. Here's the greatest problem with this thing is it has only 2 levels of heat: hot and crazy hot. All right, and that's a problem. You need to get used to cooking with it. Okay. In the same workshop now, yeah, they had this woman who came to cook and she said, "Can you make the fire smaller?" And I said, "No, we can't. It just burns really, really strong." But they didn't, because they're freaking crazy about fire. They made an experiment, and they got a kind of rocket stove like this to the point where it was so hot that they melted metal inside without any air pump. So there was this metal worker there that said, "I've never in my life seen a fire burn without having to pump oxygen into it, melt metal." And it's this kind of basic design that they did. I'm looking forward to seeing them. They just arrived and I haven't seen them yet. And so
Assuming you would limit air intake, it would limit also efficiency.
the way to control the heat basically is how much wood you put in and how deep you put it in. So if I just put a smaller stick and I'll put it outside, the heat will be smaller. If I put it in, there's more surface of wood that's burning inside.
The physical way of controlling the burn is to limit air intake.
I suppose you can, but I think it would make the construction much more complicated. I mean, maybe if you build it from metal and you put some kind of slot that you can control, you could do this. But honestly, it's too simple to want to mess around with. To me, it's about learning to cook with it instead of how to make it more complicated and air intake and all this. It's tempting, but I don't believe it's the direction to go. Look at it.
What implication does it have for centralized or autonomous heating systems? And if people live in the flat in the city,
Yeah.
how can they use
Okay,
this?
so this is a different question because there is the problem of legality. Are you allowed to build this? And the Americans have had some interesting experiences with this because in America everything is regulated. Fortunately, here in the village, I did not have the problem. I just built it and nobody cares and nobody knows. I'll answer your question from a different direction. And if it answers, fine. If it's not, ask again, okay? Now that I know how to build a rocket stove, we're studying how to build a new house, an eco house. And the question is, do I want to put a rocket stove? The answer should be, of course. But I'm now looking at the design of a house where it would be 21 degrees in winter without any heating. So, the best rocket stove is the one that you don't need. But if you build them properly, if you build them with mass heating, if instead of a cup bench, you run the chimney inside the wall back and forth, you can have a warm wall. So I've seen documentation of one rocket stove, one rocket mass heater, heat a 3-story house. Okay, but again, it's not just a rocket stove. It's how efficient is the house. It's a lot of things that affect the performance of it. So I know about rocket stoves, and I hope to build a house where we won't need one.
Okay.
Give that answer. What time is it? Yeah, 40 minutes, and all the wood is still here.
We were shooting for 34 minutes.
And all the wood is still here. Can you imagine? Look at this. We cook like forever with nothing. That's where we get them. We want to one day try making them, but we haven't gone that far. Yeah. Now that I know this, I see every evening in headquarters how they cook on this open fire and just pains me. You cannot know this and cook any other way. I mean, I cannot know.
What's your favorite food that you cook?
French fries.
Except Zakluska.
Freedom.
I